I want you to imagine that it's the 1870s. So a long time ago in terms of technology, not that long ago in terms of human history. I mean, you might live in a house that's around that age or older potentially. But in terms of science, a long time ago. 1870s, we didn't know anything about inside an atom. So we knew that atoms, that elements were made up of atoms and that an element has only one type of atom in it, that sort of thing. But we didn't know about electrons, protons and neutrons, the nucleus. Certainly we didn't know anything about any of that. We've just got to the stage in technology and science where we can create a partial vacuum. So we've got a pump, and we can pump, we can get low pressure with this pump, and there's actually a better pump coming along, a mercury pump, which can create a better vacuum. And we've also got to the stage where we can create really high potential difference using an induction coil, which is a very, very crude type of transformer type thing, actually, that can produce really high potential differences. So we're around there. So we've got this tube. This is full of hydrogen. It's relatively easy to create produce hydrogen in the lab. Full of hydrogen. It's sealed, obviously. Got a metal spring in this end, a metal spring in this end. Doesn't matter, it's a spring, but it's connected up to my circuit. I've got a 5,000 volt supply here. Got low pressure hydrogen gas, or fairly low pressure hydrogen gas. And when I turn it on, then this happens. And the gas is clearly glowing. The question then for these scientists in the 1870s was, why is this happening? What's actually happening here is that you've got such a high potential difference that this is what's actually happening, you're ripping electrons off of some of those gas atoms, causing them to become gas ions. And those gas ions, if they're going to be accelerated towards the negative side of the supply, the gas ions are going to move towards the positive side of the supply. The gas ions are going to move towards the negative side of the supply, and the electrons are going to move towards the positive side of the supply. The ions, they're a lot larger than the electrons, and they're going to have a lot of energy. They're going to move through the partially evacuated, so the low pressure gas. If it was high pressure gas, they might collide with other atoms. It's low pressure gas, so they're going to move through, and they're going to be attracted to the negative side here. It's going to collide with that, and it's actually so much so that electrons are then released from there, and those electrons are going to be accelerated the other way to the positive side of to the positive plate, and they're going to move very fast, and they're actually going to interact with gas atoms that are in the tube itself, and so they're going to excite those gas ions or gas atoms, and then they're going to de-excite, and we're going to end up with emitting this light. So we've got excitation from collision with electrons, and we've got de-excitation, which emits this. And we know, because this is hydrogen, this is a very specific frequency. We've done about that in waves, because they're falling down a very specific gap in your energy levels, maybe a couple of gaps that make this kind of pink colour, because pink isn't on the electromagnetic spectrum, so I'm assuming actually it's maybe a couple of gaps. And actually I should know that for hydrogen, there's 3 visible ones, aren't there? Sorry. And so it's producing this light, and that's what they managed to do. They also, though, managed to get an even better vacuum. And when they got an even better vacuum, something else was happening. So I'm just going to show you that. When you've got an even better vacuum, what they noticed was, and actually it's not quite like this tube actually, what they noticed though when they had the better vacuum is that past those 2 plates, on the very edge of the glass, where there was a glowing coming from there, and they didn't know what was causing that. They didn't know what was causing the glowing of the gas in the tube either. And they called them cathode rays. So basically the idea of a ray then hitting that glass at the end. We've got a similar setup here, but this actually involves a heater, and so that's thermionic emission, which is the next chapter in what we're doing. But a similar setup here, where we've got negatively charged here, positively charged here, a very good vacuum, so pretty much a complete vacuum, and we've got 4,000 volts over it at the moment, and so that's causing electrons then to move. Now, this is actually such a good vacuum that there are no real gas atoms to speak of, and so our electrons here are actually coming from this heater. The filament, this negative side is being heated, but in their tube they had a bit of gas, and that meant that, similar to the setup before, we had the gas ions moving and the electrons moving. Those electrons were moving very fast, and they were missing that positive plate at the end, or some of them were, and they were hitting the glass, and they were glowing off the glass, and they called those cathode rays. And this is a cathode ray tube in a sense, because we've got that kind of ray, if you like, and I've got a phosphor screen here so you can see really easily that it's coming, that there's a light coming off the glass there, but their tube was different from this at the time, when they had a better vacuum. But they did find that they had a glowing past the positive plate, which they weren't expecting. And they called these cathode rays. Essentially what they've done is discovered the electron. And we're talking about people like William Crookes and J.J. Thomson, and people that are credited with the discovery of the electron. J.J. Thomson went on to do some other stuff and to find the charge mass ratio of an electron. But just preliminary here, we've found this weird stuff's going on, and because we've got kind of light coming out of it as our output, we're calling them cathode rays, but we know that they're electron rays, if you like. They're electron beams, that's a better way of putting it. They're electron beams, but they call them cathode rays.